On November 2nd, 1917, the 100-inch telescope is finished. Its 100 tons of iron and steel move with the precision of a fine watch. Its 9,000-pound mirror can detect a candle 5,000 miles away. What Hale has built is one of the marvels of the 20th century. It will reign for decades as the best telescope in the world and prove beyond doubt the worth of big telescopes. To spend a night here is the dream of astronomers the world over.
You would open the dome, a kind of rolling like thunder, and you were alone on the mountain with a telescope. It's just you and the universe, or you and God, so to speak.
You'd sit at the platform at the telescope, guiding, making very fine adjustments on this magnificent instrument with a little hand paddle, with your eye staring down onto the illuminated crosshairs, and work there 8, 10, 12 hours.
Oftentimes it was extremely cold. In winter they wore heavy coats, sometimes they wore bearskin or sheepskin coats. You could literally have your tears freeze to the eyepiece, and they wanted hot coffee, but Hale wouldn't allow it. He thought it was poisonous to the system.
20 hours.
Coffee isn't all that Hale keeps off the mountaintop.
In the 1920s, I would not have been allowed to work up here. In fact, I wouldn't have been welcome even as a wife or a visitor of any of the scientists. Hale, in his days at Yerkes, had found that the wives of some of the astronomers became a distraction to their monastic scholarly studies, and so they were essentially banned from the mountaintop.
Ironically, without the contribution made by a woman, the first great discovery made with the 100-inch might not have been possible.
The closest a woman could get to the field was, at the time, at the Harvard College Observatory, where major data collecting projects were in progress. Women were hired on to help to analyze the data, to do all the menial tasks that were below the duties of the men.
Henrietta Leavitt is one of a dozen women who studied tens of thousands of photographic plates taken by men at distant observatories. Leavitt's task is to examine plates taken at different times and look for stars that vary in brightness. She notices a pattern in one class of stars, called Cepheids, and realizes the time it takes them to reach their maximum brightness can be used to determine how far away they are. It's a landmark discovery. Before Leavitt, astronomers couldn't calculate the distance to any but the closest stars.
What Henrietta Leavitt did was provide one of the first, and still to this day, one of the most fundamental yardsticks in the universe. It is the measure by which all distances are determined. Without that, we'd be clueless.